Good evening, students. So till now we have seen um, the IUPAC nomenclature for acyclic compounds. That means which are not round shape, which are chain structures, like these compounds we have seen. Now we will see the IUPAC nomenclature for cyclic compounds. Cyclic means what? Cyclic means, suppose we have this structure. This is bond length formula for N-pentane, because this is one carbon, second carbon, third carbon, fourth carbon, fifth carbon. So this is N-pentane. N-pentane. Now in this N-pentane, suppose we join the first carbon and last carbon like this with a bond. Then it becomes like this. So this is nothing but cyclopentane. Cyclopentane. So this is cyclic compound. That means in acyclic compound, open chain structures will be there, and in cyclic compounds, closed chain structures will be there. This is cyclopentane. Suppose we have this one. This is cyclohexane. And suppose we have this. This is cyclobutane. 4 carbons are there. Cyclobutane. Therefore, for this type of compounds, how to give the IUPAC nomenclature? Here, one example is given. That is nothing but it is cyclic form of pentane, so it is cyclopentane. So another example is given. This example. So here, methyl group is there here, and third position, this propyl group is there. So this is methyl, this is propyl group. So obviously in alphabetical order, M comes first, after that P comes. So this we have to give the first numbering, because it is M, methyl. This second carbon, this is third carbon. So here total carbons, how many carbons are there? 1 carbon, 2, 3, 4, 5, 6. 6 carbons are there. So it is cyclohexane system. So the name of the compound is 1 methyl group is there at first carbon, 3 propyl, cyclohexane. So that is the name of this compound. And another example is given is this one. So the structure for that one is given like this. 2 methyl groups are there here, and 1 ethyl group is there here. Okay. So in this case, we need to give the numbering to the carbon which is having more substituents. So this is also 1, 2, 3, 4, 5, 6 carbons are there. So it is cyclohexane system. Hexane system. So now in this cyclohexane, 2 methyl groups are there. This is 1, this is 2, and this is ethyl group is there, ethyl. So obviously ethyl gets first preference in alphabetical order, but numbering will be given to that carbon which is having more branches. That means this carbon is having more branches. So obviously that should be given number 1. So obviously it is 2, and we have to give numbering in that direction which gets lower numbers to the substituents. So in this direction, clockwise direction we have to give, so that ethyl gets 3. If anti-clockwise direction like this if we give, then ethyl gets 1, 2, 3, 4, 5. So we have to give the numbering in such a way that clockwise direction to get ethyl third carbon, that means number 3. So name of the compound is third position, ethyl is there. So E should be written first, because in alphabetical order E is there. So ethyl, 3 ethyl, 1, 1 di methyl di methyl cyclohexane, because it is cyclic structure of hexane. So cyclohexane. So this is the name for this compound. Okay, 3 ethyl 1 comma 1 dimethyl cyclohexane. So numbering should be given in such a way that the more number of substituents. So here on this carbon 2 substituents are there. On this carbon only one substituent is there. So this carbon gets number 1. But while writing the name, this ethyl group we have to mention first, because in alphabetical order we get E. After that we get M. Okay, so 3 ethyl 1 comma 1 dimethyl cyclohexane is the name of this compound. Okay, so now let us see some problems are given here. What is that problem? Structures and IUPAC names of some hydrocarbons are given below. So this one hydrocarbon, this one structures are given, and names also given. 2 names are given. 2 names. So one name is in bracket, another name is without bracket. Okay, explain why the names given in the parentheses are incorrect. That means the structure in the bracket, this name is incorrect, but this name is correct. The above name is correct, the below name is not correct. So that is how he is telling. So here the above name is 2 comma 5 comma 6 trimethyl octane. That means this carbon is 2, this carbon 5, this carbon 6. So if we give the numbering from left to right, the substituents will get numbering 2, 5, 6. But if we give the numbering from right to left, then substituents will get the number 3, 4, 7. Obviously 2, 5, 6, 2, 2 plus 5 plus 6. How much it is? It is 13. And 3, 4, 7. 3 plus 4 plus 7. Obviously it is 14. This is the lowest number. Obviously lowest number we have to choose. That means we have to choose the numbering from left to right here. So the name of the compound is 2 comma 5 comma 6. 3 methyl groups are there. This methyl group, this methyl group, this methyl group. 3 methyl groups are there. So 2 comma 5 comma 6 trimethyl, it is octane. 8 carbons are there totally. Up to here 8 carbons are there. So it is octane. It is not like 3 comma 4 comma 7 trimethyl octane. We have to give the numbering from left to right, because that gives us total 13. From right to left we are getting 14. So we have to go for 13. Actually this one. Okay, that is a solution for that. And another one is given. The name is here also same. Means if we give numbering from this side, ethyl is getting 3. If we give numbering from right to left, methyl is getting 3. So in alphabetical order, E comes first and then M comes. So ethyl should be given lower preference, methyl should be higher preference. So ethyl should get number 3 and methyl should get what is that number 5. So we have to give the numbering in such a way that ethyl should get 3. That means left to right we have to give. So when we give the numbering from left to right, it gives the name 3 ethyl 5 ethyl heptane. So that is the answer for that one. Now nomenclature of organic compounds having functional groups. What is this functional group? Functional group means, okay, what he is telling, functional group means A functional group is defined as, earlier also we have discussed, functional group is an atom or a group of atoms bonded together in a unique manner, which is usually the site of uh, reactivity, chemical reactivity in organic molecule. That means if we have ethane like this, propane like this, uh, this carbon, this is carbon, this is carbon, but instead of this carbon we have OH group here. So this OH is functional group. It is a functional group. And suppose we have like this propane, and we are giving bromo here. We are giving bromo here. So this bromo is a functional group. And if we have like this, and we are having a functional group like this, it is aldehyde functional group. And if we have propane like this, and here we have a keto group, so that is a functional group. So functional group means an atom or a group of atoms. Here simply, in this case, it is simply an atom, bromine, but here combination of two atoms, oxygen and hydrogen, and here it is combination of three atoms, carbon, hydrogen, oxygen, and here combination of two atoms, carbon and oxygen. So functional group is a single atom or a group of atoms. Generally, functional group decides the properties of the compound. So properties of the compound depends on functional groups only. That means how it looks like. It is solid or liquid or gas, or it is having a bitter smell, or it is having sweet smell, or it is going to give you which type of properties, chemical properties, physical properties. Everything depends on the functional group only. And all the compounds which are having same functional group are grouped as a separate group. That means here compounds having the same functional group undergo similar reactions. For example, methanol, ethanol, and isopropanol, all having OH functional groups, liberate hydrogen and reaction with sodium metal. That means if methanol is there, CH3, OH. If we react this with sodium metal, Na, sodium metal, then we get hydrogen gas. Liberate hydrogen gas. So instead of methanol, if we use ethanol, C2H5, OH, and react with sodium, it also liberates same reaction, because same functional group. This is also OH, this is also OH functional group. If we react with isopropanol, sodium, then obviously it also liberates hydrogen gas. So functional group is same, so reaction is same. That is what he is saying. Hydrogen gas and reaction with sodium metal. The presence of functional groups enables systematization of organic compounds into different classes. That means all the functional group, one type of functional groups are combined into one type of group. Okay, systemization. That means so many functional groups are there. So different groups of compounds are there. Like alkanes are one group, alkenes one group, alkynes one group, like that. Okay. And aldehydes one group, alcohols one group, like that. Different types of compounds are available. Okay. So examples of some functional groups are given in a table 8.4. 8.4. What is that 8.4 table? Here table is there, 8.4. If you see, so many functional groups are given here. So alkenes, alkynes, like aldehydes, nitriles, ethers, and with their functional group formulae. and prefixes for this IUPAC nomenclature, and their examples also, and suffixes also. So like that it is given in 8.4, and when we come to the table we will discuss everything about that functional group. Okay. In the case of polyfunctional group, in the case of polyfunctional group, polyfunctional group means, suppose we have this OH here, one functional group, this side we have bromo, this side we have bromo. So this is one functional group and this is another functional group. So out of these two functional groups, first number should be given to this carbon which is attached to OH, and then we have to give number to the carbon which is attached to bromine, because priority list is there. Priority list, that priority list is this one, priority list. In the priority list, OH comes first and bromo comes next. So the one in the priority list comes first should get first preference, and second preference to the next member in that priority list. So that and all we will discuss in the next class. Okay, thank you.